Okay, continuing on with our Laplace Transform playlist, we have today an interesting Laplace Transform. We want to find the Laplace Transform of the second derivative of f of t. Now, the Laplace Transform of derivatives is really important when we're solving differential equations, because we're going to come across this in a lot of cases. And now, in a previous video, we found this formula down here for the first derivative of f of t. The formula we found for that is just s times big F of s, which is just the Laplace Transform of f of t minus the function at 0. So for this Laplace transform here of the second derivative, we're really going to just use what we found in the other video on the first derivative and just kind of repeat it and just kind of manipulate this in order to get our solution for this. So what I'm going to do to try to make this a little more clear is I'm actually going to rewrite this. I'm just going to rewrite this in a slightly different way. So I'm just going to kind of put the function in parentheses to make it clear and just show that we're taking the derivative of that function, which is the same thing. It's the exact same thing as this, but I just kind of want to show it this way. And then here, I'll put it back in this form. Instead of writing with big Fs, we'll write this just as the Laplace transform of f of t, just to show that we're getting the Laplace transform of this input right here. And then for the last part, we just have this function at 0. But just to make it clear, this is evaluating this function here at 0. So I didn't really change anything, but I just kind of want to show it that way. So it's going to help us, because we need to be really clear when we do this. Because for this Laplace transform, what I want to do is get it where I can use it in this form. So I'm just going to take this, and I'm going to write this as the first derivative as our function, and the derivative of that. So that's the same thing as the second derivative, just kind of getting it where we can clearly use this form. So then we're just pattern matching using this. We're going to have for this s, and then we're going to have the Laplace transform of this input here, which is just f prime of t. So we'll have Laplace of f prime of t. And then we just have the input function evaluated at 0. So we're going to have, this is going to be just f prime at 0. But now for our Laplace of f prime of t, we have that right here. We'll just use it in this form and plug this back in here. So this is going to give me s times this in parentheses, s big F of s minus f of 0 minus f prime of 0. I'll just distribute in the s. This is going to give me s squared big F of s minus s f at 0 minus f prime at 0. And so this here is going to be our formula for the Laplace transform of the second derivative of f of t. So now let's just build on that and do this again to find the Laplace transform of the third derivative of f of t. And we'll do the exact same thing. We'll just rewrite this. That's not the best L, but we'll keep going. This is going to be, we'll write this as the second derivative of t. And we'll take the derivative of that in order to get the third derivative. But that allows me to use this formula over here. So we're going to have s, the Laplace of this input, which is just the second derivative of t, minus the input function, so minus just this second derivative evaluated at 0. But then this right here, that's what we just found. We have this formula right here, so we'll just plug that in. So copying everything down, we'll have our s, and then we'll have all this stuff, which is going to be s squared big F of s minus s f at 0 minus f prime at 0. And then we can just distribute this s in the same way we did last time. So what we're going to have here, this is going to give me s cubed big F of s minus s squared f of 0 minus s f prime. And then we just have this last piece minus f double prime of 0. So this will be our formula for the Laplace transform of the third derivative of f of t. Okay, so now that we have a formula for the second derivative and a formula for the third derivative, we could go on to find the fourth derivative. We could do this again for the fifth derivative. We could keep repeating it and repeating it and repeating it all day long until we have the 900th derivative. But instead of calculating this over and over again forever, I think what I'd rather do is just kind of notice the pattern. For the third derivative, we'll just write this 3 right here. We notice that's the same power on our s, and then the power on the s decreases by 1, right? We go from s cubed to s squared to s to the 1. You can think of this here like an s to the 0. And then in every case, the first term is going to be our big F of s, and the second term is going to be f of 0. Even for the first derivative case, right, this still holds. So we always have these first two pieces. But then what's going to happen on the f of 0 terms is we get increasing derivatives. Like we have the first derivative here evaluated at 0, and we have the second derivative here evaluated at 0. And it turns out if we call this 3 value we started with as n, this value here is just always n minus 1. So all we need to do is just notice this pattern, and we can generalize this and write this as a formula for any derivative. Okay, so here we have our formula for the Laplace transform of the nth derivative. I just want to make that clear so you know it's not an exponent there, that's just a derivative. And like I said previously, this is just the same pattern that we saw here. Like we start with our s to the n and we subtract 1 on the s all the way down until we have s to the 0 here. And we have this increasing derivatives for our f of zeros. And again, we start here with the big F of s and the f of 0. And of course, it's kind of an ugly formula that's hard to remember, but if you kind of remember the pattern and the decreasing exponents and the increasing derivatives, I think it's a lot more easy to remember that way. That's the way I do it anyway. But if you happen to forget, I have a link to my Laplace Transform cheat sheet in the description. Anyway, that's it for today. In the next video, we'll do a differential equation that uses the second derivative. Thanks everyone for watching. Have a good day.